if sine alpha plus beta is equal to 1 by 3 and cos alpha minus beta equal to 2 by 3, then the greatest integer less than or equal to this is. Clearly alpha lies between 0 and pi by 4, beta lies between minus pi by 4 and 0. The concept I'm going to say now is not very necessary here, but this concept at many other places may be very useful, and many times I use this concept, and that is because it is easier to deal with positive numbers rather than negative numbers. As beta lies between minus pi by 4 and 0, I take beta equal to minus lambda, and because beta lies between minus pi by 4 and 0, it means lambda will lie between 0 and pi by 4. That is, alpha also lies between 0 and pi by 4, lambda also lies between 0 and pi by 4, and because it is easier to deal with positive numbers, minus lambda instead of beta, because minus can be adjusted here very easily. Agreed, it is not very useful here, but at many other places it becomes very useful. And now, first writing the whole question in terms of lambda, I get sin alpha upon cos lambda plus cos lambda upon sin alpha plus cos alpha upon, because it is sin minus lambda, hence I will write minus sin lambda, and similarly minus sin lambda upon cos alpha whole square. And according to the given information, sin alpha minus lambda equal to 1 by 3 and cos alpha plus lambda equal to 2 by 3. And with the help of these two, I have to find the value of this. It is obvious that we'll combine this with this and this with this, because this is given to us. Agreed, this will also be correct if I combine this with this and this with this. And for clarity purpose, I will do this question by both the ways. Actually, even if I combine these two and these two, if you do calculation, you will find that that way also gives the answer, but that way is too much lengthy. Therefore, I will not prefer that way. But the method which immediately comes in the mind just by looking at the question with the help of given information is combine these two and combine these two. This thing flashes in the mind immediately. Hence, combining these two and these two, what I get sin alpha sin lambda minus cos alpha cos lambda upon sin lambda cos lambda, and plus here I will get cos alpha cos lambda minus sin alpha sin lambda upon sin alpha cos alpha whole square, and further it is minus cos alpha plus lambda upon sin lambda cos lambda plus, here it is cos alpha plus lambda upon sin alpha cos alpha whole square. This is equal to cos alpha plus lambda whole square into minus sin alpha cos alpha plus sin lambda cos lambda upon sin lambda cos lambda sin alpha cos alpha whole square. And cos alpha plus lambda is 2 by 3, hence it can be written as 4 by 9. And further it becomes sin 2 lambda minus sin 2 alpha upon 2 sin lambda cos lambda sin alpha cos alpha whole square. Four by 9. Keeping these two in mind, where alpha is first, lambda is afterwards, it will be preferable to write sin 2 alpha minus sin 2 alpha, because a square is there, no any problem is there in writing it. I get 4 by 9 sin 2 alpha minus sin 2 lambda upon 2 sin lambda. Here lambda must have been there, hence cos lambda sin alpha cos alpha whole square. The difficulty which seems to be coming is in the denominator, and how to proceed with the denominator I will do it separately. Hence, for simplicity, I will find the value of numerator separately and denominator separately. First, I am proceeding with the numerator. I will be getting 2 cos alpha plus lambda sin alpha minus lambda, and the value of both of them is known to us here, as I had derived these from these two. Therefore, now the problem of numerator is over. Hence, the value of this will become 2 into 2 by 3 into 1 by 3, that is 4 by 9. Hence, the value of numerator becomes 4 by 9. And the next thing to do is to find the value of this. There are so many methods of finding the value of this. For clarity of concepts, I'll find the value of this in 3 ways. You'll enjoy this. Note that I told you in the very beginning that I will do the question by this way also, where I will combine this with this and this with this. I told you in the very beginning that even combining this with this and this with this will also give the answer, but that way will be very lengthy. And now, to find the value of denominator by first way, first I am writing this as 1 by 2 sin 2 lambda into sin 2 alpha. To find the value of this by first method, I will be writing it as 1 by 4 2 sin 2 alpha into sin 2 lambda, that is equal to minus 1 by 4 cos 2 alpha plus 2 lambda minus cos 2 alpha minus 2 lambda. We can write it as minus 1 by 4 2 cos square alpha plus lambda minus 1, and this thing you can write it as 1 minus 2 sine square alpha minus lambda. And using these two values of cos alpha plus lambda and sine alpha minus lambda, I'll be getting minus 1 by 4 2 into 4 by 9 minus 1 minus 1 minus 2 into 1 by 9, that is minus 1 by 4 into 10 by 9 minus 2, that is equal to 2 by 9. Hence the value of this we have got is 2 by 9. That is the value of this is 2 by 9, and value of this I got was 4 by 9, which was the value of this. And now putting back the values of each, I will get the result 4 by 9 into this value is 4 by 9, that is 4 by 9 upon this value is 2 by 9 whole square, that is equal to 4 by 9 into 4, that is 16 by 9. And because it is 1 point something, hence I can say greatest integer less than or equal to this becomes 1. And as I promised that I will be finding the value of this by 3 ways. First way of finding the value of this already told here, and now let us find the value of this by second way. Note that in previous way I had started from here and next step was this, and in the other method instead of this direction I will proceed in this way, that I will write this portion as sine lambda plus alpha plus lambda minus alpha. Similarly, I will write this as alpha plus lambda plus alpha minus lambda, and this is equal to 1 by 2. Take this as A and this as B, I get sine A minus B into sine A plus B, that is I get 1 by 2 sine square A minus sine square B. And now because alpha plus lambda has been taken as A, alpha minus lambda has been taken as B, hence I can say sine B is 1 by 3 and cos A is 2 by 3. Hence I get 1 by 2 1 minus 2 by 3 whole square minus 1 by 3 whole square, that is 1 by 2 1 minus 5 by 9, that is 2 by 9. And previously also I had got the answer 2 by 9. Or third method of finding the value of 2 sin lambda cos lambda sin alpha cos alpha, I proceed as from here I can say sin alpha cos lambda minus cos alpha sin lambda equal to 1 by 3. And from here I can say cos alpha cos lambda minus sin alpha sin lambda equal to 2 by 3. And see now, if I square and add these two, note that after squaring the term of the type 2ab, you will be getting 2 sin alpha cos lambda cos alpha sin lambda, and here also you will be getting the same thing in the term of the type 2ab when I will square and add. You can see very easily that after squaring and adding cos square lambda into sin square alpha plus sin square lambda into cos square alpha plus sin square alpha minus, here you will be getting 2 sin alpha cos lambda cos alpha sin lambda, and here also you will be getting the same thing minus 2 cos alpha cos lambda sin alpha sin lambda, actually both are same, and here you will be getting 1 by 9 plus 4 by 9, and now you will be getting 1 minus 4 sin alpha cos alpha sin lambda cos lambda equal to 5 by 9, and this is 1 minus 5 by 9 whole upon 4, and this is equal to 1 by 9. Hence the value of sin alpha cos alpha sin lambda cos lambda is 1 by 9. Hence the value of this becomes 2 by 9, as I found in the previous way also. That is, I have found the value of this, which is 2 by 9, by 3 methods, and putting back the values of all, I'll be getting the answer 4 by 9 into, recall that the value of this was found to be 4 by 9, hence writing 4 by 9 upon writing this is 2 by 9 whole square equal to 4 by 9 into 4, that is 16 by 9, and because it is 1 point something, hence greatest integer less than or equal to this is 1. And now I will be doing the question by another method, in which I will be adding these two and these two. If we proceed in this way, we will be getting sin alpha cos alpha plus sin beta cos beta upon cos alpha cos beta plus, and here you will be getting sin beta cos beta plus sin alpha cos alpha upon sin alpha sine beta. I'm writing only the inside portion. Squaring can be done afterwards. This is equal to, and numerator can also be written as 1 by 2 sine 2 alpha plus sine 2 beta into 1 by cos alpha cos beta plus 1 by in the previous method I had taken beta as minus lambda, and for more clarity I have kept beta as it is in this way. This is equal to 1 by 2 sine alpha plus beta cos alpha minus beta, and here you will be getting cos alpha minus beta upon sin alpha cos alpha sin beta cos beta. And the value of this I have already found by 3 methods previously, and that was 1 by 9. The value of this I had found was 1 by 9. And now putting back the values, I get 1 by 2 into 2 into sin alpha plus beta is 1 by 3, cos alpha minus beta is 2 by 3. 1 by 3 into 2 by 3 into again 2 by 3 upon 1 by 9. This is I get 4 by 3. And because the inside portion I have got the value as 4 by 3, hence the value of this whole becomes 16 by 9, and therefore the greatest integer less than or equal to this becomes 1.